admit that this was no flying saucer.
Alright guys, this is what I've done so far. I decided to go 4 poles each coil. I didn't go for 5. It was too close to the south bisected the last coil. But anyways, this is our positive, so the connecting shaft, and this is my starting point. I started right here, and then I did G1, and then I did G2. You can see pretty tight there, and this is gonna stay there. This is it. So this is the G2 will start right here and will end the last coil. So I'm going from here that way. And then I did the other side, like I told you on the forum. It's to compensate balance weight, the motor on both ways. So I started from here and did exactly G11. So I'm doing here G11 and G12. Okay, and you can see that I'm going. So the way this works is I'm gonna keep going this way, and here I'm gonna keep going that way. So there will be a point that I am going to start winding here, and that will be my last starting point, like I show on the diagram. It's when I cross the number 1 coil, and this section here, when it crosses and finds its way down here, that'll be our ceiling points. But we'll keep building, gonna keep building that way and this way till we meet the starting points right here. So we gotta mark both in red, or making some mark that you won't come off with your hands. These are permanent magnets, permanent markers. And make sure you don't lose your track though, because this is kind of tends to confusion. You gotta keep growing, jumping 1 slot. I'm gonna do now G3, then it will start here, and G4 and G5, G6, G7, G8, G9, G10, and G10 it's gonna go starting right there, and G11 is gonna start right where 1 was. Follow? So that's the way they overlap, and that will be my last end layer of coils, and so on when I grow this side up. So got an idea what it looks like, and I'm gonna put it. I already put it on the starters, and I checked it out, because this is already. And this is 20 gauge. It was not 18. It's 20 gauge, and it's giving me approximately 0.5 ohms per coil, per group. So that's pretty good for the way that we're gonna hook this motor. So, all right, that's guys. It so far. I wanted to make a stop here, and the reason is because I have wounded 5 groups on this end here, and 5 opposed at 180, 5 more, and I am completed with the whole thing. And I mean, this is 5 on 5, and this is a 20 pole, so we are actually have 50% achieved so far, and it's like we are doing right here, like 2 of the 4 quadrants of the 360 degrees. And if we theoretically stop right here and put it on the cat, we'll have the motors, say for instance that these are the motor coils, 5, and then we need 5 more that are gonna be filling up this side right here. Now at this point we have to keep doing 1 and 1 or 2 and 2. We cannot do like 4 and then, or 5 and then 5. Why? Because they start interlacing here, overlapping. This over the first one that I did, which is right here, and I marked the pole where I started. So right here, number 5 on this end, it's already overlapping over 1. So the next one is going to overlap here and so on until we get all this section right here filled up, and so on from this end right here. It's going to go that way until I got it all filled up. So I got 5 on this to go, going that way, and 5 going that way. So you keep track, and there's at a certain point I mark here 1 and I put here a 2, like 1 and 2. So I got a guidance on it. Besides, I marked the top of the commutators, and I also marked the poles. The first pole on the first coil is right here where it starts lapping. So if you look at it on the diagram, you'll see that right here we got 2 that we already have 4 this way going that way, but then I'm gonna have 4 coming this way, and this is what you have to calculate. I have used so far 6 turns per coil, and there are 4. So but then again, the advantage of this type of winding is I can reduce at the end to maybe 5 on each, and it would not affect just 1 less turn on this, because it's spread it through 4 coils in the whole group. So actually it won't make that much of a difference. All right guys, now I have completed one whole side right here, and you can see the point where I start. It's right here. Let me get the zoom here, so see the mark that I did here. See, I put a 1 red sign right there. So, and then you can see how the outer layer of the finished grooves are overlapping on top of the starting points, which is very down there. See the first group right there. So it is a lot of work, and there's a lot of I have not finished putting the insulation on the bottom yet. I just been hooking it. So you see basically how this ends the spiral here, but then there is another one coming right underneath. So these layers of grooves are lapping at it at the same token they are on top of the starting layers. And so now on this side that is not completed, I still got 2 more groups to hook, and you can see there the starting point is right here, and let me get the camera. Starting point is right here, and I'm missing 2 more groups that are gonna contour on the outside. It's very important that you keep using a small mallet and a piece of wood, and you gotta keep etching this backwards so you can have feet for the new groups, the new coils in, and so on the bottom. Because I know, because of the upper shaft is right here, you concentrate your attention on the upper part and forget about the bottom, and we tend to do that. Please don't, because then you see I did forget a little bit to keep controlling it, and I'm gonna have some kind of hard trouble getting the hedges here, but you know that has to be pushed in with wood, always wood or plastic. This is like a putty knife. I already broke it because I've been pushing it this way in here like that, and it's the only way not to scratch the enamel from the clear enamel coating on the wire. But here we have, and I finished this one up, and again I was doing 1, 2, and 2 on the other side, and 2 and 2 and so on. So right now I finished winding this one. I figured to film it so you guys see how actually this is much more work than doing the pairs. Much more. I mean, I'm talking it's I've been 2 days working on this, and of course not a full day, but like 6 to 8 hours each day on this thing, and non-stop. I mean, just take a break to cool off my hands and keep going. But anyways, this is gonna be a massive machine here, and I can feel it. It is gonna be like a non-stop generation of electricity and motoring, and since the whole thing is just fluctuating, the flux is just going in the same direction. It's just gonna create the spiral we talk about in the flux in the same direction. So it's gonna be a pretty neat machine once that I get it mounted on and tested. So it's just a matter of putting it pretty. I'm putting the hedges on. I'm not going to you know, permanently solder this, but just press it to make sure they're not gonna come loose. But this is just for testing purposes, that I'm just gonna do it like that and finish it. But of course I do have to run the hedges because of the speed that I'm planning to run it at. And yeah, it's a nice looking winding. Okay, the final stage, all put together. The wire retainers on. Just gotta tap a little bit of glue in here so they don't slide. Some of them are not that, but they won't roll off. But just to make sure, I cleaned out the commutators, as you can see, so that if we got any bad sparks, we could check them out later on. Like the north-south, they were creating like some arcing on the edges of the commutators, and I don't believe the Old North is gonna do that. So this is the final product, and we can see the actually there are 2 spirals in here, and they're easy to identify. It's one is born here and develops all the way to the exterior, and the other one is born underneath there. You guys saw it previously, and then it develops all the way over here. So if you look at it, it's like that, 2 spirals. And yeah, I'm gonna take it for a small test drive and see how it goes. Alright, so this is the final assembly of the rotor and all put together here, and it's a 20 pole. I use 20 gauge, and it's according to this diagram where I'm using 4 poles, and it's got 4 groups, I mean 4 coils on each group. So but I'm grabbing 4 poles, 4 poles, 4 poles, 4 poles. So, and what I did is I run different wiring for each independent brush, so it'll be 4 and 4, and not, it was before was like factory connected. So yeah, and Now the way this motor is, it's got adjustment here, so it's at the max that way, so I'm gonna have to readjust it for better timing. Okay, here is a final assemble, 20 pole, all north, in groups, and as shown on the winding tracks. And something I want to say about this motor specs, and I'm gonna put them on video while I talk. It has a nominal voltage of rated of 24 volts, and the nominal current amperage draw, it's 40 amps. It develops a speed of 3300 with that 750 watt, which if you do the right math is it's not 40 amps but somewhere around 29. Anyways, specs, speed, voltage, and amperage, it gives you an idea to compare versus these asymmetrical wind. Now the way I have it hooked is as I mentioned on the winding process, I'm feeding the positive right here, the two positives. It's connected in parallel, and you can see join the two positive, the two negatives right here, and it's gonna be showing the input is gonna be shown on that first meter there. And I'll make sure the scene, yes, and this one right here is connected to the output, which is in series. And here you can see the two positive, negative, black, red, white, black, red wires hooked on. Now I want to do a simple test first, and it's about a 1.2 volt battery that you have seen before. And if I measure this battery voltage without hooking it to the motor on that meter, it is gonna show me 1.395 volts. So it is charged, and we're gonna see what it does when I connect it, this little battery, to just the input. See, it's turning the motor, showing there an output of 0.5 volts. It took somewhere around 300 millivolts, and it's developing, yes, very low speed, 145, sorry, 86, 90 RPMs. But this is something that would never be able to achieve it with a symmetrical motor. It would be impossible. Why? Because we are only turning two groups at the same time, and they're very low resistance, anywhere in between 0.7 to 0.8 with the brush resistance. Excuse me. And you can see the draw there. And if I read the amperage on this, it's gonna show 3.5 amps, which for this battery it's kind of odd, but it's what it reads. But it's amazing that it runs, and it's like a clock movement. Excuse me, now it's going 98, 99. As a matter of fact, it's increasing RPMs. 99 now. And you see the output has increased also. 0.7 volts. Now this delivers, it shows the accuracy of this type of machines, that it could be run with such a small battery. And of course it's not reliable, but it's just showing something that the symmetric would not ever achieve. Now it's understood that if I connect a bigger little pack, still below 3 volts, which is this one right here, 2 AA's, and just gonna hook it real quick here and do a measurement. It's 2.7 volts. We see that it's gonna run stronger. Now steel is gonna show about the same amperage, 3.6. And this is good to observe because it's gonna keep developing around the same amperage no matter how many volts we add to it. Of course, now it's going faster. It's going 2600 RPMs. I'm sorry, 396. And it's developing, outputting 2.9 volts output. .58 remains around the same value. Now, as I keep going with voltages tests, it's a rate of this type of battery right here. It's a LiPo, a lithium ion, 1350 milliamps hour, and I'm just gonna hook it right here and see what it does. And I'm gonna do the same thing, just check the voltage first, and it shows 11.94 volts. So just gonna kick it. And it's 4.39 amps. With the LiPo of 11 volts. And it is developing 2500 RPMs. Now I get to connect this one. These are two twins. They're similar. They're 1300 to 1350 milliamps. Just gonna hook it. And let's take a reading of this. It's 23.27. And now these are the specs of the original motor. It's drawing 4.68, 4.59, and it's doing 4,300 RPM. and it's producing 26 volts. I want to test this battery here, which is the ones I've been using on before. They're 35 amp hour, 12 volts. And I'm going to hook it in here, and I'm going to run it through the negative. And let's take a reading of power here. It's 12.28 volts. And it's doing the same, even less, 4.12 amps. I'm developing 2700 RPM. And it's putting out 20 volts on the output. It's about 4 amps right now. And it's doing 2760. It runs very smooth, as you can hear. I still believe we can do some minor adjustment on the magnets. I have not done that, still at the factory specs. And I can move them about 1 notch back. Thanks for watching, guys.